Hello everyone, this is Professor Amit Solanki from SND College of Engineering and Research Center, Yeola, District Nasik. Welcome to the online lecture series of the subject PECD. Now we will continue today our next braking method, that is the plugging. As earlier we have discussed the different methods of electrical braking like regenerative braking and dynamic braking. Now this is the last third one, braking, that is the plugging. In that we can see that if the armature terminals are supply polarity of a separately excited or shunt motor, when running are reversed, then the supply voltage and the induced voltage will act in the same direction, and the motor current will reverse and producing the braking. So means that our main objective is to producing the negative torque, right? If we are producing the negative torque, so automatically it is called the electrical braking. So as it is in case of plugging, what we do, we can reverse the polarity, we can reverse the connection. If we reverse the polarity of the armature supply voltage, then what we do, then the braking torque or negative torque will be developed, and this is called the braking, and this type of braking is called plugging. This type of braking is called the plugging. In the case of series motor, either the armature terminal or the field terminal should be reversed. Okay, in case of series motor and we can do that, the armature terminals are field terminals. Reversing of both gives the normal motoring operation. Okay. In that you can see here in this circuit diagram, first this is a separately excited motor. This circuit diagram is shown the motoring mode of operations, and this circuit diagram is shown the braking mode operation, or we can say that this is a separately excited motor and this is the series excited motor. Okay, in that you can see here we have reversed the polarity or the terminals. In case of motoring, here will be plus in minus, but we are considered as a braking. So in that we have changed the terminals, the polarity. Here is plus and here is minus. We have changed, we have reversed the terminals for the armature. In case of motoring, here is A1 and here is A2, but we are shown is a figure that is a braking. So in that we have reversed here, here is A2, here is A1. Same is in series motor. In case of same will be happen in the series motor. So this is the basic function, fundamental concept of the plugging, another type of braking. When running at the rated speed, the induced voltage will be nearly equal to the supply voltage V. So therefore, at the initiation of braking, the total voltage in the armature circuit will be nearly 2 volt. To limit the current within the safe value, a resistance is equal to twice the starting resistance will be required. The performance characteristic of separately and series excited motor is given in the figure, that is the speed torque curve for the DC motor under plugging condition, or we can say that the plugging. This portion is the dotted line is show the series motor braking, and the straight line and the shaded line is shown as a separately excited braking methods. Okay. Since the braking torque remains sufficiently large from the rated to zero speed, so therefore change in armature circuit resistance during braking is not necessary. Okay, and the braking torque is not zero at zero speed. So when used for stopping, an additional arrangement is required to disconnect the motor from the supply at a near zero speed. Otherwise, it will speed up in the reverse direction. Now we can say that plugging is a highly inefficient method of braking. braking. Plugging is a highly inefficient method of the electrical braking. Not only is power is supplied by the load, but also the power taken from the source is wasted in the resistance. So for that we can say that plugging is a not a sufficient method. It is a insufficient method. Okay. So these are the all about the concept for the electrical braking. Three types of braking we have studied: regenerative braking, dynamic braking, and plugging braking. Okay. Thank you.